A lot of people often ask me how to compute derivatives in a program, and this seems pretty much very difficult to them, but it's not actually. When you understand the very basic logic, what's happening behind it, then coding parts become very easier for you. So we would be using C language for that, and if you understand the logic behind that, you are going to implement with any other language. That's totally up to you guys. And the basic requirements for this video, I'm expecting that you must be knowing basic trigonometry, and that would do enough. And if you know a little bit about curves and lines and equation of tangent to a curve, then that's spectacular. And we're going to go with C language, as I told before. So the function that we are going to use, the polynomial equation, is very simple. We are going to use x cube as our polynomial equation, and we know derivative of x cube is 3x square. And so I have already implemented all of this for you, and if you can understand, then it's good. Otherwise, I'm gonna explain this all after a while. So I have this macro defined phi x, which will return x raised to power 3. Then I have this function phi dash x. So phi dash x is explicitly returning 3x square, because we know differentiation of x cube is 3x square. Then this is the function differential that we are going to discuss today. So if you can understand this, take a screenshot, give yourself a time, and if you're understanding this, then you can go right away. Otherwise, this is the main function, and we have an infinite while loop, and we have a double x value which we will take from user, and then we are simply printing phi x, then phi dash x, and differential x. So the purpose of this program is that differential x and phi dash x should return same value. So we are going to explicitly define a function phi dash x which will return same value as the gradient function that we are defining is differential x. So I'm gonna just show you these all functions in real. So I have this Jupyter notebook, and you don't need to worry about NumPy and Matplotlib. The function we care about is x cube, and this graph shows how x cube looks like. Then again, 3x square would look something like this. So I'm gonna run it. So this is the graph for 3x square, and both of them together would look something like this. This is the function of both. Now in my notebook, I'm gonna show you how tangents of equation work. Okay, so we have this right angle triangle, and I expected you to know trigonometry, so I'm gonna pick up a marker. So just look here, we have this right angle triangle, and then this is the angle theta, and the tan theta is given by perpendicular upon base. You should know that. So this line is the perpendicular, and this is the base. And comparing this with the triangle on left, we have x2 y2 as b coordinate and x1 y1 as a coordinate. So this line, the perpendicular, would be y2 minus y1, and the base, it will be x2 minus x1. So what this means, okay, what this means if we plot a graph, so I'm gonna just plot a graph. So this is x-axis and this is y-axis. So this is x, this is y, and we have a point here. So we are taking it x1 and 0. So this will be y1 x1, or you can write it otherwise, but sorry, we usually like to write it like x1 y1, but I wrote it y1 x1. Now we have another point which is at x2 0 on x-axis, so it will be y2 x2 or x2 y2. Now what I'm gonna do, I'm gonna create a triangle. Bad drawing. So this is that triangle we are talking about. Now look here, this is y2 from there to there, and this is y1 because y is a function of x, so we are having y1 and y2. So this area, this will be y1 and the remaining one will be y2 minus y1. Similarly, on x-axis we have this coordinate as x2 and the left coordinate as x1, so we are going to write it as x2 minus x1. Now if we calculate tan of this theta, it will be perpendicular upon base. So perpendicular upon base, so perpendicular is y2 minus y1 and base is x2 minus x1. So how the tangent works, it's exactly same as it is shown in left, which is y2 minus y1 upon x2 minus x1. So this is actually the tangent of a curve. We are denoting change in y coordinate upon change in left coordinate or the x coordinate. Now we have this equation y is equal to x cubed that I show you on Jupyter notebook, and we are going to plot it on x naught is equal to 3, as I have implemented it already in the program. So I'm going to show you how the program would work, and I will put the link to my GitHub repo in description and you can access the code from there. So 3 would lie somewhere like that, and we need to shift it a while towards left, and here we go. So I have taken value of epsilon as 1 raised to power minus 10 . See, I'm gonna show you that. See, this is the value of epsilon, which is actually delta, the change, 1 e minus 10, so it is 1 raised to power minus 10. So x1 would be x naught minus delta, and x naught we are taking 3, so this is our x naught. Then this would be x2, which is 3 plus e raised to power 1 raised to power minus 10, which is 0.000, 10 times 0 then 1. And similarly on x1 we will have 3 minus 0.00000, 10 times then 1. And now how we calculated that tangent was x2 minus x1 that divides y2 minus y1, right? So y2 is basically fx2 and y1 is basically fx1, and so this is that formula that we derive, y2 minus y1 upon x2 minus x1. So we are going to put that here, and upon x2 minus x1. So putting the values, okay, so x2 was 3 plus 0.0001, which makes it 3.000001. You can manage it by yourself. Then x1 was 2.9998, subtracting 0.001 from 3, it gives us 2.999999, 10 times. You can calculate that, you are smart enough. Then we are going to calculate same. I'm little lazy, so I'm trying, but it's not happening actually. So I just calculated, just copied the zeros out of that above equation to calculate x2 minus x1. See, I have crossed limits of being lazy, then I'm gonna just put it 2.9999 minus, and then this is 3.0001. so this is that equation, fx2 minus fx1 upon x2 minus x1. So right away we knew the derivative of our function is 3x square, putting x naught is equal to 3, so 3x square will give us 3 into 3 is square, that is 27. And what happens in practice is that this value will also give us 27. So you can just solve it. Go ahead, do cube of fx2 minus cube of fx1 or x1, and then putting x is equal to 4, similar things will happen, just we will have to shift these lines. And so what we're going to do, we are going to copy paste it here. So 4.001 would lie something here, and oh my god, and then copying it here. So 3.99999 would be somewhere like here, and we can just calculate it right away. So I'm gonna show you this code. Does it really work? See, the value of epsilon was e raised to power minus 10, means 1 raised to power minus 10. Then we have x1 as x minus delta, x2 as x plus delta, and then y1 is equal to x1. We calculate function of x1, then y1, then grade is equal to y2 minus y1 upon x2 minus x1. We just actually copied this formula and use it here, and the gradient will directly come to us. Okay, so that's all what I did. So I'm gonna put value of x is 3, so answer is 27. See, that's what we were expecting, right? Because differential is giving equal value to the gradient. And then we have this in a infinite while loop, so I'm gonna give value 4 this time, and see, the value is 64 for y-x, but 48 and 48 for gradients, because 4 square is 16 and 3 into 16 is 48. Again I'm gonna just run the exe file, and this time we are gonna give value 2. So 2 would give us 8, because 2 cube is 8, and then 3 into 4 is 12. 3 into 4 is 12. So I guess this gives you quite an intuition about how differentiation is working. Similar with 5.